Good day, everybody. Welcome back to the Concord IA Renewal Series. Today, you'll be listening to me. I'm Tom Maher from Camp Systems. I'm a 19-year field service rep. I've been directly supporting the Dassault Falcon Jet line, as well as the Pilatus and Daher manufacturers and customers. I'm an active technician and pilot, and I travel the country supporting these manufacturers and service centers and our shared customers, fostering aviation safety and helping assure customer aircraft are maintained in a safe and efficient manner. My additional activities include participating in the FAA safety team. I'm a local representative here at the Little Rock FSDO, and we're supporting both the technician and the pilot community with the aviation maintenance technician and the Wings Pilot Proficiency Program, as well as other industry safety programs. Just a little bit more about me. I'm a aviation high school graduate, New York City public school. I paid $40 in shop fees for my A&P. I am a trade school advocate, and anybody these days that's looking for a pipeline of mature, certificated young adults looking to get their start in the industry, I would highly encourage you to reach out to the high school and plan yourself a visit. They'd be happy to see you. So for today, we're going to discuss maintaining and protecting the asset value of today's modern turbine aircraft. We'll use the Pilatus PC-12 NGX as an example. We'll discuss 6 action areas: best practices to maintain dispatch reliability, mitigate excessive maintenance costs and downtime, protecting the engine and propeller, knowing your support team, protecting asset and resale value, and ensure we're providing maximum value for every maintenance dollar spent. So here we go, section 1, best practices to maintain dispatch reliability. For me, these hover around ground power use, the battery, windows, software, storing, ground handling, and taxi. So jumping right into ground power. For maintenance, we should be using a ground power source, especially for doing things like nav database updates and other cockpit work without having to pull the aircraft out the hangar. There's a lot of reasonably priced and useful tools out there now to support those efforts. Some are shown on screen here. And ground power for starting. This is a heavy electric airplane, so we have to respect that battery capacity. And so the less we use just straight battery power, the better. So when we have an opportunity to do a start on ground power, I highly recommend we execute on that. We have, again, new ways of doing that. We have these power sticks with a pretty robust ability to start an engine 5, 6, 7 times. We got a classic diesel generator, and even today now we have these battery power carts available to us. So ground power for starting, highly recommended. And battery maintenance, we touched on that a little bit earlier, right? This is a heavy electric airplane, right? So battery is a critical, important item for aircraft like these. And for our friends at Concord, right, they make some pretty robust recommendations and the documentation they supplied to the operators and the mechanics. So here from our battery owner operator manual, something to consider, right? The only reliable method to determine battery state of health is that capacity check. Aircraft storing. When the aircraft is placed in storage and it's going to be dormant for an extended time, it's always best to disconnect the battery. Lead acid batteries become sulfated when they discharge for extended periods of time. And the longer that discharge time, the greater the depth of discharge, the worse that sulfation becomes. And that's kind of our battle for battery maintenance. And down at the bottom here, another factor for that sulfation is repeated short duration flights. Operators of this class airplane, we witness a large portion of flights of less than an hour, sometimes only 45 minutes or even 30-minute hops. So we're putting a lot of starts on a battery, which doesn't even have enough time in flight to bring the charge back up. So something to consider as we as we maintain these batteries. And just to kind of put icing on the cake, here's a quick snippet from a given time last week of the PC-12s in flight and across the USA in the mid-afternoon last Wednesday. And you'll see here these times, 1 hour was the long one. And, some of these flights were down, only 10, 11 minutes. So again, that, the battery's up to the challenge, but we got to, if we don't get the opportunity to bring it back up to charge with a long duration flight, something like 2 hours or better, we need to consider that as we manage the maintenance on those batteries. And for that deep maintenance issues, Concord supplies us with those component maintenance manuals. They give us some very specific criteria when we're testing the aircraft, the battery, right? So if we do the cap check and we pass at 90% or above, we're good to go for another 6 months. If we pass somewhere below 90 down to 85, we have to bring those checks and roll them back to every 3 months of service. And if we pass that cap check at less than 85%, it's time to remove that battery from service. So all of that stuff we did as far as using ground power for starts and doing the avionics, database uploads, all of that we do lets us keep that battery in the game longer. Also, when the aircraft is sitting, right, there's a nice trickle charger for the battery, also highly recommended. This is something else we can do to kind of keep that sulfation at bay and keep that battery in play for us. So when we hit the start button, we're going to have all we need from it. Every battery comes with its own logbook. So there's a place to document when we're doing these checks and keep track of the service life of those batteries. And even better, using a maintenance tracking provider such as CAMP, right? We can track that for you and do the countdowns for you and keep track of all the paperwork as well. And in cases for aircraft like this that have two batteries, they don't have to be on the same schedule. They can each be on the appropriate schedule for that battery's condition. So again, maintenance tracking comes in real handy for keeping those things in view. Next topic, windows, right? A lot of drama can happen around windows. When these windows have a problem and it has to be replaced, the price tag starts at $15,000. So care and caution around windows. There's a lot of discussion, across the industry about, do we use internal window covers, or do we do external window covers? What's better? Some people just wrap the whole airplane up in a cover and say we're good to go. For me, I'm of the don't touch the windows unless absolutely necessary. And we definitely do not want to be touching the windows with paper towels. Whatever you elect to do for window protection and cleaning, make sure it is in alignment with the manufacturer's instructions. Damage caused using products not on the approved consumables list will not be covered under warranty. Damage, scratching, hazing, delamination caused by cleaning methods and other mishandling techniques outside the manufacturer's published instructions will not be covered under warranty. And just a couple of samples of what looks good and what could be questionable. Foam cleaning the airplane, I'm liking that. This guy's using a hose down in the bottom left, that looks great. Even a flight crew can be trained on how to properly wash the window without damaging. And then lastly, we should never be hitting these things with a squeegee or a credit card or any sort of rigid device to clean the windows. Software. The PC-12 today has at least 13 software packages that need to be managed and maintained over the life of the aircraft. There's componentry called the aircraft personality module within the Honeywell architecture. This software identifies and brings to life the existence of how all this avionics knows the airplane exists, the options installed, the rigging of the airplanes, kind of all in this encapsulated into the software, this system that is now integrated into the whole airplane. So, how significant can software updates be? That's always an interesting question. I like to lean on the GTN 750 to kind of answer that. So here we have, you see this a lot now in fleet. Here's a software version update. It was optional from the manufacturer, and it was not warranty reimbursable. And if you read down some of the descriptive text, you'll notice that this corrected an issue with the CDI possibly deflecting in the wrong direction, away from the desired track. Now, I'm an instrument rated pilot myself, and that kind of got my attention. And I thought, well, what does that look like? Right. So I'm asking for a friend. Are software updates important? I'll let you decide. Also, too, we are now writing ADs against software. Here's a AD that's in the proposal pipeline right now, written against specific Garmin autopilot software identified at a particular revision level. So again, another reason to keep track of the software in the individual systems that we've integrated into the aircraft. And the FAA's even done some research for us and advised us that for $85, we should be able to get in and out of the avionics shop with the software update. I don't know if that's how it's going to play out, but that just does seem a little low for me. Storage and protection. Everywhere I go around the country, there is a shortage of hangar space, right? Don't get pinched into stuffing this high-dollar aircraft into a tightly packed community hangar. It's better to park a little further away from home than to spend money fixing a hangar rash. And just to put a nail in that one, this is an actual one of my local tenantry here in Arkansas. I came across this and I'm like, well, it's not my airplane, and I definitely will not have my airplane parked under that. Also, weather is a consideration, right? We have to watch the weather, especially when the aircraft is parked away from home base, or us mechanics are out on a ramp for maintenance runs. Down here in the south, some of these weather systems can come honking across, the ramp at 60 miles an hour, kicking up hail, rain, excessive winds. So, stay alert, protect the asset. Sometimes it's better to keep it in the hangar and try again tomorrow to get the runs done. And then also, hurricanes don't typically sneak up on us, but when big stuff is going to happen, it's often the best option is actually just temporarily relocate the aircraft. And flooding is a risk more and more these days. Just the last 2-3 years, we've seen a lot of flooding damage occurring on the airports. It's always a tough one when the airplane's away from base and you have a flooding incident, and then you have all the drama of trying to either salvage, save, or relocate the aircraft after an incident like that. So again, be aware of what's going on. Flooding is a risk for airplanes too. Ground handling and taxi, that's another place where we see a lot of drama. Here's a PC-12 and a 172 that tried to occupy some of the same space on the taxiway. Did not work out. It was an incident where somebody parked a truck on the runway, and there were some other disagreements in play. But again, we're not gonna take off through the truck. But these things do happen. We have, and it's always better just to be conservative and be aware and be careful when we're moving these aircraft around. And it happens to the pros too. Here's the Irish Air Corps. Basically, they towed their PC-12 through the back end of a CASA. And I always like to zoom in on this one because this damage section here actually shows us how nice a job Pilatus does applying the corrosion preventive compounds inside the structure. That's that kind of hazy yellowish brown compound you see there. So well done, Pilatus. Also too, when our pilots and operators out, running around the country with the aircraft, it's good to have that ground handling equipment on board. this stuff is light enough now, and storage places are built into the airplane for it. It's almost a shame not to have it. And even having something as simple as a ladder it can make cleaning those windows, if we need to, a much more successful effort. And the manufacturers provide us additional guidance for that. They'll have, in this case, the ground servicing guide from Pilatus, which identifies all the tools, cleaning products and such we can use while we're cleaning and moving the airplane around. So that's some of the best practices for maintaining dispatch reliability. If we can keep the drama from happening in those areas, that's already half the battle. And now we're going to move on into the next section, mitigating excessive maintenance costs and downtime. This revolves around maintenance planning, troubleshooting, aircraft washing, de-ice boot maintenance, and interior cleaning. Right? With the available maintenance tracking tools like CAMP, there's really no reason for anybody to ever be surprised of what maintenance come up. Owners and service centers can have access to the full complement of aircraft records and data, on CAMP, and those tools are available to assist in the research and planning efforts required of the pre-maintenance input. Right? Maintenance planning. Depending on the aircraft configuration, typical annual work scope will be approximately 212 airframe engine and propeller inspection points. Pilatus has done a great job with their chapter 4s and chapter 5s. They've identified for us which collection of inspection items should be done to be considered an annual inspection, because you'll learn in the Pilatus documents that there is no annual inspection. So it's a collection of packages, and they give us a service letter 200 educating us and identifying what collection of those packages are to be done on an annual basis to cover us for our 4315 annual inspections. And oftentimes I find sign-offs referring to Appendix D of Part 43 in these aircraft. And I always ponder that, because the Appendix D only has like 49 line items written, 40 plus years ago, right? And it telling us it's an annual 100-hour inspection, the things we shall do, right? And then 4315, they're going to tell us each person performing an annual inspection shall use a checklist while performing that inspection. My hope is it is above and beyond that appendix, and that you're using the manufacturer's inspection packaging to get that annual done. But whatever you do, make sure the checklist you use is up to the task at hand. And again, for the planning, right? Even before you show up for the inspection, we can be planning for what's going to happen to the airplane after the annual. So we can project out beyond the upcoming annual to even the next inspection, and take a look at that stuff that's going to come due post-annual. And you'll find things like, batteries, generated brush checks, right? These are the stuff that we may be mathing out to come due sometime after the annual, but it's often convenient and more economical to do some things early, since the airplane is in maintenance at that point, rather than the expense of repositioning or running time out and sending somebody remote. So again, some nice tools there in CAMP to kind of help manage and facilitate that visibility. And as well, you can even in advance start to scope out this work and provide it to the shops and use it as a bidding tool to agree to a work scope on an aircraft with a customer in advance. So again, no surprises, right? We have a nice clean maintenance package and work scope expectation, right? And we can use that information to start to work on the logistics that we have to prepare for, the ordering of parts in advance, the ordering of service bulletins or kits, so we have the stuff on time, on the time the aircraft arrives, and not waiting 6-8 weeks after it arrives, right? Because prior planning facilitates the successful execution of maintenance input and output commitments. And customers just love a no surprise, on budget, on time delivery. And at the end of that work scope, it's just simple matter to get your CAMP updated again. Just an email, fax@campsystems.com, put the appropriate PDFs of your scanned log entries and certs and whatever else you feel we need. Email it to us, and we'll take it and run. We'll incorporate it into the aircraft status, build the history into it, and make all of that stuff visible online and archive, for the life cycle of the aircraft. Troubleshooting, using data coming off the aircraft to your advantage, right? There's a lot of information now where the airplane is able to broadcast and communicate outbound. So here, one of my favorite cases here. So we had a PC-12 that had a CAS message. It was a flap speed exceedance. So we can pull the data out using the tools we have in camp. And we can see here that we're at flaps, 5 at 169 knots. If we go to the flight manual, we'll see, okay, 15 degrees or less, no faster than 165 knots. There's our exceedance. It's a real exceedance. So there's some, an opportunity here to work on some operating technique. But there's also an associated overspeed flap inspection when you have that occurrence. When you go to your chapter 4s and your 5s, you'll find those actions, and you'll see here where they've identified where certain NDTs will have to take place. And we even have a sample of these things actually do crack. So we have to be careful of our operating limitations and operate the aircraft, within the published guidelines. But in this particular case, we'll dig a little deeper. Here's our flight manual limitations. This is what the pilot's running with. 15 degrees or less, no faster than 165 knots. So we got our CAS message, and we go to our unscheduled inspection for flap overspeed, and you'll notice we have some additional instruction, right? So we got the trigger at 165 knots, and then we have a no action required 170 knots or below. So this is good because we're off the hook. We don't have to do that NDT now. Had we hit 180 knots, we would definitely be doing that NDT. If we had exceeded 180 knots, we'd probably be making a very expensive phone call to Pilatus to find out what the next action was. So the good thing, using the data, we can know before we go, right? This costly flap overspeed work scope was averted because we can prove that the flaps were less than 15 degrees and at a speed of less than 170 knots. So we saved the owner the downtime and the money, $4,000 to $8,000 if nothing broke. And we likely saved the pilot's job too. So that's a large cost, averted by 0.62 knots. That's money in the bank, and more than pays for the camp subscription. So again, getting to the data and using it to make real money-saving decisions is just the benefit of using this stuff. In another case, so we have some other tools in our application where we can kind of monitor the lowest battery voltage seen during the start. So over the several years of that particular battery's life cycle, we can see the voltage trending lower and lower during the start, as well as the ITT trending higher and higher. So we can make some decisions now. We can get out in front of that battery, either do maintenance, cap check it, recharge it, cycle it, test it, and then or maybe it's just time for replacement. But in this particular case, it was time for a new battery. It got changed, and immediately the lowest voltage seen during the start improved from 15 to 19.5 volts, and our ITTs seen during the starts decreased from 710 to 625 degrees. So again, it's a real useful way of using the information to make sure we got the most life we can at that battery, and took it out of service before we caused any damage caused by a hot start or slow starts or hung start. So, utilizing that data, we make the right call, the right maintenance at the right time, in getting the maximum useful life out of that very expensive battery. And as a technician, now you can show with data how that battery is performing and legitimately recommend what and when such maintenance can be done to sustain or improve battery life. That's how you can positively assert yourself and give your customer a valid choice. You're well done. Aircraft washing. All I would like to say is, I love a clean airplane, but please make sure we do the appropriate lubrications afterwards. Especially with sometimes I see pressure washers being used. It becomes even more critical to lubricate after. But following your manufacturer recommended guidance, they're going to tell you for the Pilatus, after you do that wash, you got some specific lubes that they would like done. The ice boot maintenance, right? We're in that time of year now where ice, is a regular daily factor. So we take care of these boots all year long, apply this protective agent, throughout the year on the schedule required. And then that's how we make sure those boots work for us when we're going to need them. Interior cleaning. We're going to leave this at follow Pilatus and Honeywell's cleaning recommendation. This interior material is expensive. These glass cockpits are expensive. We do not apply random cleaning products to these screens to clean fingerprints and stuff. Honeywell gives you some very specific guidance on that. And for the cabin cleaning, one thing I always recommend is no pens, no crayons, no markers in the cabin. Everybody's using an iPad or an iPhone anyway. There's no reason to bring ink on board. And because I've never seen a pen go on an airplane and not leave some sort of ink stripe behind. So something we can do to kind of mitigate some of that and keep that very expensive and fine leather, looking sharp. So that we're checking the box on mitigating some of the excessive maintenance costs and downtime. And we're going to roll right into protecting the engine and propeller. These are going to revolve around engine rinses and washes, engine condition trend monitoring, oil trending and consumption sampling, engine prevention when inactive, and some key propeller care. So rinsing and washing. Pratt's got a very impressive service letter out there, 206. Ties us into some of their other maintenance manuals and advisory circulars. Key point here is these compressor and turbine watches are what we can do to enhance the durability of the engine by reducing the onset of sulfidation attacks on those turbine blades and preventing salt deposits from damaging the compressor section. All pilots and maintenance should be aware of this stuff. There's a section of the country that can kind of be seen as identified as a severe corrosion environment. This is coming out of the Know My PT6 engine app. Regular borescope inspections of the compressor and the turbine blades are what we can do to help establish that our wash schedule is up to the task. We might need to wash more often, depending on how and where we're operating, or we could get away with less wash. Again, our borescope inspection kind of gives us the visibility to that. It's always recommended to perform that compressor turbine wash immediately following the compressor wash, because when we do this compressor wash, we're going to send all of that goo and bad stuff into that hot section area. And then when we do that turbine wash, we have an additional adapter where we can direct some clean water and flush out this area, get the soap byproducts out, as well as the contaminants. And again, kind of putting reality up against the map. This was a mid-Tuesday afternoon, I think about 2 o'clock in the afternoon, all the PC-12s in flight throughout the country. You can kind of see that we're pretty much operating in the severe and moderate corrosion area per the advisory circular. And when we dig a little deeper and get into the engine documentation, figure 602, you'll see there's even an expanded map where basically 2/3 of the country is actually a moderate to severe corrosion environment. So we need to consider that when we determine what we're going to do for washing schedules. As well, some of the performance loss caused by excessively dirty compressors can actually show up in our engine trending as well. And just, to do these washes, right? The manufacturer does a great job giving us about 9 very important cautions and warnings. The number one, most important one, I think, is let's not electrocute anybody. We do have a high voltage ignition system on here, so proper precautions apply. Because tomorrow we don't want to be that person that caused the safety briefing. So read your cautions, read your warnings, and make sure you have the proper maintenance manuals available. So your compressor desalination wash. This is what's used to remove salt deposits, light dirt, and it's a drinking quality water wash. We're not using soaps and stuff at this point. It's basically a drinking water wash. Now, if you're ramped at a place where the drinking water is questionable, which is often found at a lot of the smaller general aviation airports, definitely feel free to use bottled water, or demineralized water. I would definitely go down that route if the water is questionable where I'm doing this. And of course, if the aircraft has a compressor wash ring built into it, great. If not, use the appropriate handheld wand and the appropriate safety precautions to inject that water into the engine. And now a compressor performance recovery wash, this is one that's going to kind of be a call when we see the performance degradation in our engine trending. We might get to the point where we make the call to do this performance recovery wash. This is a more assertive wash using water and some improved chemical additives that'll dig into those deposits and salts and other garbage that's kind of hanging out in our compressor there, and break that loose and let us flush that out. Again, we're only going to do this when performance loss is noticeable or trend monitoring indicates. The compressor turbine desalination wash, we touched on that earlier. So after we've rinsed and pushed all of that goo to the hot section of the engine, we're basically going to do a turbine desalination wash back here with clean drinking water. It's another adapter placed in the hot section, and we're going to flush out the remaining residual materials from the hot section there. Also, let's not forget the exterior, right, of the engine. This is, again, just drinking quality water as well. Refer to our engine maintenance manual for the procedures there. And this is the battle, right? The sulfidation, right? We're trying to keep these blades and hot section pieces in play as long as possible, right? After the first start, this is where we're all at, mild sulfidation, right? Our coating has started to deteriorate on the very first start. The depletion of the chromium and the base metal is not started yet. We want to keep all of that raw material in play as long as possible. This is a great blade, acceptable for continued operation. Once we get to stage 2 and we start to see some oxide failure and roughness in the surface is evident, right? This is where the depletion of that chromium from the underlying alloy has started. We may or may not be able to keep this blade in play. We'll probably be subject to repetitive inspections. So decision times, can be deferred possibly. But again, our borescope is going to come in handy in helping us keep an eye on that. Later down the road, things have gone too far, and basically we're into the base metal of the blades. It's time for this blade to go. That's stage 3 severe. And then things like perforation, things are really bad if we get to this point. We've blown holes through the blades and the vane ring and such, loss of structural material. This is an immediate, got to get it out of the engine. We don't want to fly that. And back to the rinse washes, right? We want to make sure we pull the drain out of that reduction, that exhaust section, because we want to prevent the collection of fluids up against the bottom of the reduction gearbox and cause all of this additional corrosion unnecessarily. So at the end of our wash and rinse cycles, we'll make sure these drain plugs are out along the way. We're going to do a quick engine run to kind of dry things out and button things up, and that'll kind of complete our engine rinse and wash. And again, to the cautions, right? We're looking for a spray of about 3 gallons a minute. So, typical starter cycles, 30 seconds, that's 1.5 gallons of stuff, right? We don't want to hit this thing with a fire hose when we're doing our washes. It's really a pretty limited amount of fluid. Using the right tools, the right equipment, the spray ring of the aircraft, we can, mitigate any risk of damage by using excessive water quantities. And also, right, let's not forget the compressor case itself. That's another place where corrosion can show up. There are things we can do strategically to kind of mitigate and prevent some of that from happening. Some additional corrosive inhibition procedures and compounds we can apply. Again, back to our maintenance manuals on that. Engine condition trend monitoring, it's one of our specialties. We can receive the data from the airplane multiple ways. I can get it uploaded directly into camp. We can email it to camp, or we can receive from systems like the Fastbox, where it's an automatic upload from the airplane, when it connects to the local Wi-Fi. However we get it, and we can use it and digest it and bring that information back to the end user with our engine analyst recommendations. We can give visibility to the actual plots if the operator or the owner or the mechanic wants to view that stuff, and even give us a call and we'll consult on it and explain to you better what you're seeing here. And then what's really nice is with our plots, we can also pin the various maintenance actions that happened along the way of the life cycle of that engine, so we know and can identify what may or may not be causing any trend shifts that we might see. As well, oil consumption trending, it's always good to talk about. This was an interesting one here. Engine consumption was fine for, more than a year. And then interestingly enough, the airplane sold, and all of a sudden it had an oil consumption problem. In the end, it turns out it's just an operator problem. We learned that these engines will all find their level point. We don't have to top them off to the full line every pre-flight. And this stuff is, $44, $45 a quart if you can get it on Amazon. So we're throwing a lot of oil out the window here, no matter how much we keep topping it off. So again, a new operator, new airplane to him, new to Turbine, kind of had the conversations, and over time you can see, okay, we kind of got him stabilized to where we re-identified the level point for the oil for that engine, and the consumption, cooled down. As well, engine oil sample trending, right? Same thing. We should be sending those oil samples and getting them tested on a regular basis and sharing that information with our shop and our owner and our engine health guys, so we can kind of keep an eye on what's going on inside the engine, get out in front of problems before they become expensive problems. Engine preservation when inactive, and this was a lot of interesting conversation on this around COVID time, and even since. So Pratt, you have to make the call ahead of time. How inactive are you going to be, right? We have 5 storage states. Engines that are inactive from 0 to 7 days. So if I don't fly today, I have started my 7-day inactive cycle. And if we go, 8 to 28 days, stage 2, 29 to 90, exceeding 90 days, and then, stage 5 is all the way out to 1 year. And if we're not doing anything there, we're talking about some expensive maintenance, right? Removing, getting it, getting it stored in a shipping container. So preservation, depreservation, and unpreserved engines, right? An engine is considered inactive when it's not been operated on the ground or in flight for 10 minutes with stable oil temperature, right? If we don't get to that, then we are inactive. If we're inactive in a severe environment, like a high temperature area, high humidity, sitting on an island in a salt-laden area, we may need to preserve that engine at the next higher schedule, just because of our local environments. And engines that are preserved at a certain schedule and have been inactive for more than a year, they should be depreserved, inspected, tested with the 91 to 1 year instructions, and then removed again and stored in the engine container. This gets important when our asset owners' businesses go sideways and they can no longer operate, or they have a death that happens to own the asset. And this is the kind of stuff that can get really critical, from the the estate and the entity that owns the aircraft. So again, work with our operators when these things happen in their life. We can kind of be there to help mitigate, excessive costs or devaluing the aircraft. So stuff to be aware of. And then they give us a plan B, right? So we can, for engines that are installed, if we run it once a week to 80% of takeoff power for 10 minutes, then we don't have to do any of that. So weekly engine runs keeps us out of the storage game, something to think about as well, right? And if we're going to go down that route, right, we need to be considering, FOD, right? Make sure our engine run area is a clean, safe place, right? But we don't want to FOD the engine out doing engine runs, trying to keep us out of a storage state. And remember too, this aircraft has almost a 9-foot propeller, right? And it's throwing off some wind off the back. So we want to be careful and conscious of the environment around us, of the taxiways, runways, of the parked aircraft, if and when we have to do these engine runs, so we don't cause damage to somebody else's asset. And propeller maintenance, it's a great propeller. There's not a whole lot to do here. A couple of detailed annual inspections, the regular lubrication, making sure our steel counterweights stay clean, and in our tap test every 1,200 hours, and taking care of our erosion shields. That's it for the prop. And we're going to do most of this at our annual inspections. Hartzell has a couple of great publications out. The Prop Owner's Manual, something I always like to make a point of, especially with my new owners, is that the calendar limits on this prop for overhauls. Hartzell has determined that the effects of exposure of the environment over a period of time create a need for propeller overhaul regardless of flight time. So in experience has shown them that even special care, such as hangering, is not sufficient to permit an extension of the calendar limit. So for our Part 191 guys that want to opt out of doing the overhaul, just take that into account. The experts, the guys that built it and know what to expect when they open it, we're kind of at risk of adding some additional expense to the overhaul when we do them late. And other propeller maintenance things, something I witness a lot is, I see a lot of coin taps with a coin of a mass much less than what's documented to be used by Hartzell. Basically, they get this 2.5-inch metal slug that weighs 3 ounces. That's what they're using for the coin test. So if you're out there tapping on this thing with the back of your screwdriver or a quarter, you're probably not really going to get the result you need to get to make the proper airworthiness decision. So again, just another quick reference to the Hartzell composite blade field maintenance and minor repair manual. 170 can get you those details. And again, the 170 manual is great for identifying the various kinds of damage and stuff we'll see on these blades through its life cycle. It's a very repairable blade, even out in the field. So always, again, refer to our proper maintenance manuals for that. And bonus propeller stuff. The first rule of Prop Club: you don't run into anything, right? We just don't hit anything, and that takes care of 90% of our problems. All right, checking the box on 3. Into number 4, know your support team and talk to them regularly. We've all seen those crews, right? The guy that does 99% of the work, it's usually I, right? And then there's one that doesn't know what's going on. The guy that says he's going to help and doesn't is always the one that disappears, right? We don't want that team. What we want is a nice solid foundation of your team, like your camp, your service center, your Honeywell and your Pratt and Whitney team, all working together to keep that aircraft up and running, helping the mechanics and the pilots and the owners make the best decisions possible with all the information shared across the different teams working with the airplane. Yeah, protecting the asset and resale value. For me, it comes down to two things, right? It comes down, it's going to be about insurance and maintenance records. And insurance is kind of a weak topic, I find, in my mechanic realm. So I'm just going to share a few insurance terms and hopefully plant the seed for our mechanics to do a little additional research on their own. Right. So insurance basically comes down to public liability, right? This covers the aircraft owner. Right. It does not provide coverage to the aircraft and passenger injuries, right? That's for the owners. The passenger liability insurance, that's protecting the people in the airplane. There's often this combined single limit where the policy writers will combine those policies. This gives them some financial flexibility in how things can be paid for and paid out. And then the ground risk hull insurance not in motion. This is a place you'll see insurance policies move. Again, like maybe the asset owner has passed away. There's nobody to fly it. We kind of touched on the preservation of the asset. Well, things can happen on the insurance side to kind of reduce some of the cost and still kind of keep the asset protected from things like fire, theft, flood, mudslides, animal, hailstorms, and other damage. And then the in-flight insurance, right? That's the stuff that covers everything else while the airplane is in flight. So I would challenge my mechanics out there. Where are you covered in this? There's a great book, it's been out a while. I think there's even a newer version now, Aviation Insurance and Risk Management. If you want to take a deep dive and to see what that looks like and where you fit in and how you may or may not be covered, highly recommend. I also witness more and more the airports I go to are actually requiring mechanics to have some sort of insurance just to even freelance out on that field. So again, something to think about, something to look into. Hopefully I plant the seed of future research for you there. Right. And then aircraft maintenance records. How important are aircraft maintenance records? Look, try selling an aircraft without them and you will find out. Lost aircraft records will devalue the aircraft. And interestingly enough, those lost aircraft records are not insured. So do not lose them. Documents such as 8130s, log entries, camp cards, warranty papers, 337s, STCs, anything used to validate maintenance, inspection actions, life limits, regulatory compliance, modifications, repairs, and the continued investment in the aircraft should be preserved. In camp, we take all of that stuff, from cradle to grave. We enroll the aircraft from the manufacturer. We'll have every piece of document that they supply us with. We'll back that up and stage that in camp in our various file sections, right? This is where our cradle to grave accountability for all aircraft records starts. And even beyond that, right? As this aircraft moves through its life cycle, right? Things like borescope results, right? Those pictures we can upload here and keep a catalog of them, and you'll be able to look at them, a year or 2 or 3 later and see how things have progressed inside your hot section, all in one place inside the application. As well as log entries from the various shops that touch the airplane. And remember too, right, in the worst case, these maintenance records are going to be looked at and they will need to be produced. So keeping good records kind of keeps us, on the right side of things, even later if there is problems with the airplane. So how important are those records? Those records are the most important aspect of validating the aircraft's pedigree and proving regulatory compliance. Absent having the full complement of aircraft records, it is near impossible to prove the asset value. Aircraft records prove the continued financial investment in the asset beyond the original purchase cost. And these aircraft records should provide a continuous accounting for all the required ADs, modifications, maintenance, life limits, and inspections at a minimum. So that's how we check the box on protecting the asset and resale value. So how do we assure we're providing maximum value for every dollar spent? Well, we're working together, right? Working with our shops, working with our service providers, working with our manufacturer teams. That's how it happens. It's teamwork. That's how we keep our customers safe, the aircraft, the value, benefiting fully from every maintenance dollar spent, earning that customer trust and business each time they need maintenance. Want to say thank you again for everybody for stopping by. When you have a chance at another time, please visit FAAsafety.gov. Consider possibly joining the FAA safety team yourself. We're always looking for volunteers. A lot of great information in here. FAAsafety.gov. Any questions? Feel free to connect anytime. There I am, Tom Maher, OEM Field Service, Dealership Service Centers, Turboprop and Light Jets. Thank you, everybody, and I hope you have a great rest of your day.